In this video, let's see the topic on design procedure for different types of footing. First of all, myself, B. Chelapriya, Assistant Professor Civil, Rohini College of Engineering and Technology, Palkulam. So, first footing is rectangular footing. Rectangular footing is to carry a column load, equal column load. For designing rectangular footing, the first step to find the column load, that is capital Q equal to Q1 plus Q2. Here Q1 is nothing but load in exterior column, Q2 is load in interior column. And step 2 is to find the area of footing, that is capital A equal to capital Q divided by QNA or QS. Here QNA or QS is allowable bearing pressure. Next step is to locate the line of action of the column load, measure from the center of the exterior column, that is x1 bar equal to Q2 x2 divided by Q1 plus Q2. Q1 is nothing but load in a first column, Q2 is load in a second column. That is one is in exterior and 2 is interior column. And x2 is a center to center distance between the column. Next step to find the total length of the footing. So capital L equal to 2 into x bar plus E1. E1 is nothing but projection of footing. And step 5 is to find the width of the footing, that is capital B equal to A divided by L. A is area and L is the length of the footing. By calculating the length of the width, we find the actual area provided, that is A0. Next step is to find the actual pressure, that is small q0 equal to capital Q divided by A0. So Q max equal to capital Q divided by A0 into 1 plus 6E divided by L. While Q minimum equal to capital Q divided by A0 into 1 minus 6E divided by L. Next step, by calculating the actual pressure, the next step is to draw the shear force and bending moment diagram. Next, determine the bending moment at the face of column of maximum bending moment. And next step is find the thickness of footing, and the last step is to determine the required reinforcement for maximum bending moment. This is a shear force and bending moment diagram for rectangular footing. So next procedure is for trapezoidal footing. For trapezoidal footing design, the first step is to determine the column load, that is total column load capital Q equal to Q1 plus Q2. Here Q1 is a load in exterior column and Q2 is a load in interior column. Next step to find the area of footing, that is capital A equal to capital Q divided by QNA. QNA is nothing but allowable bearing pressure. Next step is to locate the line of action of a column load. So x1 bar equal to Q2 x2 divided by Q1 plus Q2. x2 is the center to center distance between the column. Here next step is to find the x dash. X dash is nothing but x bar plus B1 divided by 2. Next steps to find L by 2 plus L by 3, that is L by 3 is less than of x dash, less than of L by 2 means we find the width of the footing, that is B2 equal to 2A divided by L into 3x dash divided by L minus 1. Similarly B1 equal to 2A divided by L minus B2. Next step is to find the actual pressure, that is Q0 equal to capital Q divided by A0. Here Q max equal to capital Q divided by A0 into 1 plus 6E divided by L. And while Q minimum equal to capital Q divided by A0 into 1 minus 6E divided by L. Next step is to, after the actual pressure, next step is to draw the shear force and bending moment. This is a picture for trapezoidal footing. So trapezoidal footing is nothing but the column load is the column carries an uneven load. So first one is shear force diagram and bending moment diagram. Next procedure is for strap footing. Strap footing is provided when the distance between the two footings are large, means we are connecting these two footings by providing a beam. So the procedure, first step is to calculate a length, that is L1 equal to 2 into E plus 0.5 B1. Here E is projection and B1 is width. Second step is calculate the R1, that is reaction. Capital R1 equal to Q1 X2 divided by capital S. Here capital Q1 is a load at the exterior column, X2 is a center to center distance, capital S is a center between the reactions. So next step is calculate the reaction R2, that is R2 equal to capital Q1 plus capital Q2 minus R1. Next step is to calculate the area. So A1 equal to R1 divided by QNA. Similarly, A2 equal to R2 divided by QNA. Next step is to calculate the pressure intensity, that is B1 equal to A1 divided by L1. So from here Q1 equal to R1 divided by L1 into B1, which is equal to R1 divided by A1. Similarly, Qt equal to R2 divided by L2 into B2, which is equal to R2 divided by A2. This is a pressure, this is a shear force and bending moment diagram for strap footing. So at the edges the shear force are 0 and bending moment also the edges are to be 0 and the corresponding pressures are to be pointed and the lines are to be drawn. In strap, B2 is calculated as B2 equal to A2 divided by L2 or B2 equal to root of A2. So from here B1 and B2 values are known, so we substitute in actual pressure intensity and find the value. Among these three type of footing, actual pressure should be less than of allowable pressure. So then only the design footings are to be same. Otherwise we want to redesign the footing. Redesign means by increasing a dimension, that is width or anything else of the footing, and finally we want to calculate the actual pressure, whether it is less than the allowable pressure or not. So in this video we learn about the design procedure for rectangular footing, trapezoidal footing and strap footing. Thank you.